Greg here from GregsTutoringNYC at gmail.com. We're going to go over some more grade 9 math problems. So this bunch of YouTubes I'm taking from this year's SHSAT handbook, page 252 it starts on. And I've just taken a few questions at a time. So I tutor for a lot of specialized tests in the New York City area, the ISEE, the SSAT, the Hunter College High School test, and the SHSAT. A lot of kids are taking it, and hopefully we can get through the pandemic and get into your high school choice, and you live happily ever after, right? All right, so I'm going to jump right into some of these problems. We have problem number 4, should be on your screen on the right-hand side. What is the distance in units between the points 3, 20 and 11, 5? So if we visualize that a little bit, this is your XY coordinate plane. We're going to have, what does it say, 320 is going to be somewhere about right there. And if that's 3, then the other is going to be 11. It's going to be about half of that, so it's going to be about there. 11, 5. So that's going to be your 2 points, 3, 20 and 11, 5. So we want to know the distance between those. So basically, we're trying to get the x and the y here is what we're trying to figure out the differences. And once we get those two, we can work on getting the others, right? So what we need to do is find out the difference between our y's and the difference between our x's. And that'll give us our height, the x. Well, I wrote x there. It's really y then, I guess. This is x. Your height and your distance going across. And just before I do that, I want to make sure we're still alive, because I have multiple tabs open at one time. It's sometimes hard to keep track of this stuff. Yes, we seem okay. All right, so let me bring the problem back so I can read that as well. So what we need to do is take the difference between the two numbers. So on the one, we're going to have which it doesn't matter which one you take first. What matters is you do them consistently. So you can do 3 minus 11 or 11 minus 3. But if you do 3 minus 11, you have to do 20 minus 5. And if you do 11 minus 3, you have to do 5 minus 20. Either way, we're getting the absolute value of this because we don't care if it's negative. We're trying to get a right triangle to be established here, right? So we're going to use the Pythagorean Theorem once we get through that. So so we have 20 minus 5, that's the one I'm going to take, is 15. Therefore, I have 3 minus 11 equals minus 8, or just 8. So those are our two numbers, all right? So we're going to have a squared plus b squared equals c squared. So we're going to have 8 squared plus, what was the other number? 15 squared equals c squared. So many of you know your perfect squares, so 8 times 8 is 64. All of you should know 15 times 15 immediately in your head, especially as grade 9 test takers here. Okay? You should know up to 20 times 20 in your multiplication table, just at the snap of a finger. So you need to know your multiplication table from 1 times 1 to 20 times 20, plus 25 times 25, because this number comes up often now, which is 625. So you should know what 15 times 15 is, right? It's 225. This way, during the test, you're not wasting time doing computations and perhaps getting it wrong. So we're going to have 225 plus 64, 9, 6, 7, 8, 9. So 289 equals c squared, and then the square root of 289 equals c. And from what I just said there, if you know what the multiplication table is, up to 25 by 25 or 20 by 20, then you would know what the square root of 289 is. It's 17. So c equals 17, and that was our hypotenuse, and that turns out to be our distance. So what we started out was what seemed like a simple question being asked to us, and it morphed into different areas. So on the surface of it so far, the first 4 questions of this, they don't seem grade 90. Okay, they don't seem that super tough, but they're still imploring other parts to you where you might still get the wrong answer. And was this a gridding question? Where do I have it? No, they're giving you the answers here, so that this would have been G. But you could goof up. You could have goofed up and maybe thought it was F or something. So just, you want to, as I said in the stream yesterday, I've said in many of them in the past, the SHSAT's not trying to give you nasty numbers to work with. Now 289 is kind of a nasty number, but it's not giving you anything super duper with lots of digits in it, a lot of decimal points that are multiples of weird numbers. I mean, it's not impossible, but often it's not trying to do that. So they're really trying to test, do you know the concept? First of all, you just have the raw knowledge, like do you know the formulas, and do you just know how to do this first of all? And then second of all, how to use it in more weird places. Now in the question so far, there really isn't so many weird places being mentioned here. So I'm not really liking these questions to that extent. They should actually be harder. This is testing raw knowledge, question number 4. I don't really like it from that perspective. All right, but there's still things that can go wrong here. And what you want to make sure you know is, even though they're testing pretty much a fundamental piece of knowledge here, you want to make sure you get all those right. And if they can ask it this simply, they can also ask it hard. So now we know they're going to ask perhaps a coordinate geometry question, which requires you to compute the hypotenuse of a right triangle. They're going to do that. So this one was straight up right out just asking you. But what if there was a twist to it? Okay, what if they then asked you to rotate it and ask you what that figure looked like or something? There's so many ways this can go. This could have been a multi-step word problem or something like that. And technically it was a word problem, but you know, this can go any which way it wants to. So be careful, guys. All right. The next question, let me bring that up on the screen. Okay, so this on the surface looks simple as well. It's just a bunch of like terms floating around. There's the distributor property. So all I'm doing is, I like to look at illustrations first, as I mentioned. So I'm noticing this, the distributor property, A times B plus C, which is the same as AB plus AC. If you don't know what that is, you should. Often you're going to get this too, where you have to go in reverse. So make note of that. That sometimes you have to have something where you need to go backwards with that kind of thing. And again, at least at this level, it just seems to be tapping into the minimal requirements of what you need to do or not. So let's play this through. Let me write this out. So we have 3x minus 4 equals plus 4x equals 4 minus x plus 8 times 6 plus x. Something that's happened to me over the years is I have mild dyslexia and mild dysgraphia. And sometimes when I copy these down, this is where I make a mistake. So I may be solving a different problem than is actually on the page. Now in the real test, you're gonna have the sheet where you can do the work right underneath it. Actually, I have that piece with me, and I should have done that way instead of writing this over. So, but if you copy something, make sure it is what the original problem was, or even if it's a temporary solution. There's so many kids I help over the years where they get a computation like 123 and they end up writing 120. Everybody does it. I do it. The problem is not so much that you do it. The problem is making sure and double checking that you are fixing a problem once you see it. I made a problem in the stream yesterday. So I said something was 2 and it turned out it was minus 2. You should be able to kind of get a feel for that something's going wrong or something's weird, or just, you know, in the back of your mind you were supposed to negate it. Pull those things out of you and get there, because this is where people make the errors. And sometimes the answers are close to them. Like on question 4, F and G are pretty close to each other. E and H are further away, but if you ended up getting something like 16 as the answer, like, do you just choose one or the other? Do you recompute it? Do you spend the time doing that? You don't want to, okay? And by the way, on number 4, I drew it out visually like this, which is great. You should be able to visualize it, but you should also be able to just look at this kind of a problem, number 4, and say, oh, they're probably trying to get the hypotenuse of a triangle. Now, we weren't exactly sure that's what they were doing, but if you want to draw it out, that's cool. If you're just so familiar with this kind of problems, like, oh, this is distance. They're looking for distance. And there's also a more involved distance formula. Okay, the distance formula involves taking the square root of the difference between the x and the difference between y, and it turns out that's what I did here. Okay, I still had to get the both of those, and still end up, when I got it, get the square root of it. So it's still the distance formula. I just literally didn't use it. I just did it by steps. All right? Because the distance formula is the difference between the x squared, the difference between the y squared, and the whole square root of that. So we still ended up doing the same thing. So no matter how you slice this, you're still trying to do some of the same stuff. So let me go back to here, because I went a few levels deep. Just let me make sure I copied this right. So 3 times x minus 4 plus 4x minus equals 4 minus x plus 8 times stat. So what is the solution of the equation shown above? So we're going to run out the distributor property. We get 3x minus 12, right, plus 4x equals 4 minus x plus, we have to run the distributor property again, 48 plus 8x. Okay? So what we're going to do is combine like terms. So we get 7x minus 12 equals, we're going to, that was the only constant here, so we're going to combine these two. We're going to get 52, and then we have minus x and 8x, minus 7x. Okay, no, plus 7x. See? So I just made an error, and it's just fix it as you're going. Fix it. And what happens is when you run these through, once you get the answer, you should go back and plug it back into the original formula, just to make sure you didn't make a goof up. Because even though the choice might be there, you may have done it wrong. Okay? So what we're going to do is we have 7x on both sides. If we remove 7x here, we have minus 12 equals 52. So either we made a mistake, because a constant can't equal another constant, or that's the way it needs to go. So if we look at it, 3x minus 12 plus 4x equals 4 minus x plus 48 plus 8x. So I did this correct. 7x minus 12 minus 7x plus 7x plus 52, yes. So there's really no choice here. So these are one of these ones I often like to say you should not double check once you finish the test. You should have a second solution, alternative solution mechanism available as you're taking the test, so that you can double check this. Let me just begin double checking, making sure we're live. Yep, we seem to be. So we can't get a solution here. So it's not A, it can't be 8. And by the way, if you want to brute force it, plug 8 in, right? So if you go back to the original equation over here, if we plug 8 in, and 8 here, and 8 here, we're going to get 4, right? 4, I'm going to get 12 plus this, we're going to get 60, if I did that right. And here we're going to get 14 times that, right? And this is 8, by the way. So this is going to be minus 4. So we need to get 56, or we need to get 64 over at this point. And 8 times 8 is already over 64. So we know this can't work. 65, we can plug in and do the same thing. But realize too, as you keep plugging these numbers in, you need to pace this test and you're spending time you don't have. All right? But sometimes the better way is to do the double check, especially if at the very end you have the extra time. Because this one's tricky to the extent. The answer is there's no solution. Right? And if there's an infinite number solution, it means that any x you put into it should work. We already showed x equals 8 would fail. And we can do something like making x 0. All right? So that would kick out the minus x and the 4x. And then we have 3 times minus 4 is minus 12. So that means the other side should be minus 12. And we can see already that the 8 times 6 is the 48. And that's way too large, and it doesn't work. So we can't use 0 either. Be careful when you use plug-in numbers like 0 and 1 sometimes. There's simple numbers to plug in, but sometimes they force answers to be correct, when other choices like 2 or something may not have worked. Okay? So it turns out the answer is no solution. Now, if I recall properly, let me go to the answers for this. Yeah, it says here that the answer is D. So there's a mistake here. And if we go down here, there is no solution to the given equation. All right? So they use there's an error here. Okay? By the way, let me post, I did up an errata on the, thing, on the, just give me 1 second, I'll give you a link. Yeah, it's a link to an errata I did up. I really nitpicked the document. My perspective is that there should be no error whatsoever on this document. And it turns out there was a few. There was a couple of small erratas that really didn't matter, like the bottom of some of the pages are messed up. The page number has an overlay on it and stuff like that. So I nitpicked everything. There is about 4 literal exact errors. The rest are about how it's formatting. The rest was like what springs to mind is this handbook seems to use more GPQs than normal, so that may or may not be a hint that there's going to be more GPQs on the actual test. Anyway, pick up a link of it, read it, and just see what I have to say. I nitpicked on 1 or 2 math questions as well. So whatever, just to be thorough. But there is literally about 4 erratas, if I remember correctly. I don't have it in front of me right now. All right, so that's the deal there. All right, so the answer to that is no solution. 6, again, 6 seems super easy, and yet some of you are going to be like, oh my God, we have to know what a rational number is? Yeah. As I keep telling you guys, I say make sure you know your fundamentals. And a lot of people take that like, I already know my grade 3 math. And then what you do is, there's this test called the SHSAT, which is testing certain things, and everybody flies over and tries to do AMC 12 problems, which misses the target completely. And their premise is, well, if I can do the hard problems, I can do the grade 9 SHSAT problems. And that's not really a truism, guys. That has a fallacy in it, because the SHSAT is testing certain things, and the AMC 12 and even the AMC 10 and even the AMC 8 is about a contest. So there is overlap in some of the problems, but they have different premises and different purposes. So using AMC 12 or 10 or even 8 is not really the best way to prepare for this, even though there is a lack of grade 9 SHSAT information to practice with. You need to find examples that run under the auspices of what a test is about, okay? In any event, they're going to ask you, they're going to throw out questions like this, including in the grade 8 SHSAT, of what are the number types, what's a prime number, what's a composite number, what is a consecutive number. Some of the questions ask that. If you don't know, you're screwed. What is You know, and it might be, you know, an answer. I remember a problem that I used last year, which is what type of number is the result of a square root, right? Something like that. Or what type of number is the result from an absolute value? Those can end up being questions and with answers you don't really realize. Because if I ask most people what's the square root of 25, they're going to say 5. But it turns out minus 5 is also one of the choices. Okay? And if I ask most people what's the type of the absolute value, right? They might say it's a positive number. But if the answer to the absolute value is 0, well, 0 is neither positive nor negative. So be careful on these kind of things, guys. They're going to tap into some of us. You know, oh, they're trying to trick me. No, they're not really trying to trick me. You need to master all of it. So a lot of kids are going to go, when I say why not use something that you did this year. Make sure you know your textbook completely. You know, is that it? Oh, I do. Well, then that meant every state test you got 100 on, right? Because if the SHSAT is that much harder than the state test, and it normally is, okay, then you should be able to totally ace a state test. And yet most kids never aced it. So there's still a lot of stuff. And remember here, there's only 57 questions here. Out of all your education so far, including the other stuff you need. Because the SHSAT needs, we all know it needs you to have more knowledge and more savvy than what you're learning in the classroom. All right, so you need to go that extra mile, including all your fundamental core material, like number types. All right? So this requires you to know what a rational number is. So if you don't remember, you can deduce it by looking at some of these and trying to figure it out. So there's kind of two ways to do this. One is knowing what some of the rules are. So a rational number terminates, even if it's a repeating number. Because on a repeating number, what do I do with my pen? Lost me pen. All right, here's another one. So it could be something like 1. Of course, you also know that could be 1.0. The values of those are the same. There might be different number types. Well, this you could say is a decimal number, but it's still talking about one entity of something, right? Yeah. Also, 1 is the same as 1 over 1, right? So we have truisms and identity properties like that as well, okay? But a decimal number could be something like this, or 1.1. We also can have something like 1.23, where the 3 might repeat, okay? I like to say this is still terminating because we're not actually writing the 3s. So it's either something that literally terminates, or we can write as if it's terminating. Or let's just say it straight out, it has a repeating last digit, or last digits, it could be 3, 4, as long as it repeats at the end. If it goes on indefinitely, then it's irrational, okay? So we can take that kind of definition and work backwards and say just plain old 1 is rational, but so is something like 3 over 8. So that's just a regular fraction, okay? That's rational. By the way, I mentioned before, in addition to knowing your multiplication table, you should also know what some fractions are. So if you don't know the outright rule that if you have an integer over an integer, that would be a rational number, okay? Because it's going to give us one of the other two. You should know what 1/8 is. You should know what an eighth is, okay? 0.125, okay? And on that note, you should also know what something like a 16th is, 0.0625, right? I just divided this in half. I don't memorize the both of them. I just memorized this. So 2/8 must be 2 of these, and 3/8 must be 3 of these. So if this is 1/8, then 3 is 375, 0.375. So we're showing that's a terminating decimal. That's the point of what's going on here. And you should know this in your head. You've memorized it, and you have it in your mathematical repertoire, right? And so that you're going to be mathematically fluid knowing some of these things, so that when it comes time to test day, that not only are you being able to paste this and do this example in seconds, literally seconds, On average, you have about 1.5 minutes to do it, which is that question on the whole test, including the ELA. It means including reading the passages and doing other deeper analysis. So that's on average. So there's going to be some questions like question number 6. You should take 10 seconds to answer, which means basically you get a free question thrown in on your pacing. You're going to be able to use that 1.5 minutes on another question. All right. So this is what you want to do. Plus, whenever you need to solve a math problem, if all these stuff are in there, it's like saying, oh, this is gaming the test. Oh, he's teaching me a trick. Well, doesn't that mean everything you know about math is a trick then? I mean, do you go back and compute 4 plus 6 anymore? No, you just know it's 10. So why not just know what an eighth is? Why not know that 17 times 17 is 289 in the previous example, right? Why not know those things? Why did you memorize the multiplication table when you in grade 3 or 4 or whatever? Why do that, right? For that matter, why open a door when you're walking into it? Why not crash into it, right? So there's certain 4 fundamental core stuff that you should be savvy in. And as you get into high school and deeper math, those are things you don't want them holding you back. Do you really want to be held back on 4 plus 6 or 4 times 6? I tutor a lot of kids, including kids taking the SHSAT, who actually don't know the multiplication table. Why do they need to go figure out the multiplication table when they're trying to do an advanced problem? And it means that every time they hit a multiplication, they have to do it. And then it means when they come to a problem like 1, 2, 3 times 9, 8, 7, their mind is blown trying to keep track of this using their fingers and all this other stuff. You want to be mathematically fluid on all of these things. Okay, in any event, given what I just said, 0.375 is E, that should really end it. So let's make sure the others are not that case. So pi is 3.1415, yada, 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 and everybody knows that goes on forever. Okay, the square root of 3 is between 1 and 4 somewhere, right? So that would also tend to repeat, and you'd have to figure out how to use and conclude the square root of 3. And the square root of 83 works the same way. Even if you can make it a radical, like 5 times the square root of 3, let's say it equal that, you still end up with that square root of 3 at the end. That probably it goes on forever. Okay? So there's a couple of ways to have figured this out. Let's say you didn't know what a rational number is. Well, just knowing really pi is the thing in your pocket here, because most people would know that pi has digits that go on indefinitely. Okay, and therefore, wait, if that pi is like that, what else is like pi? Okay, because even if you didn't know that 3/8 was 0.375, you could have actually divided 8 into 3 to figure out what its decimal equivalent was, and then saw it, and then put 2 and 2 together. Maybe just because the other 2 are radicals, that they might be the case. Now, G could have been something like radical 4, square root of 4, and the answer there is 2. So be careful here as you're doing these. It's not just because G and H look weird. It's because they don't have straight up non-terminating. They don't have decimal equivalents that are non-terminating or non-repeating. They just go on forever. All right. All right. So I'm going to end this here, guys. I'm going to continue on maybe every morning, just as the wind blows here, as I feel okay, and as things go on, that's what we'll do. And I'll do other ones. I'll do more in ELA. I might start a Q&A session after this at some point today, which is mainly just text-based, where you can ask any question about this or that, whether it's about registration, when is it going to start, what happens on test day, what should I bring with me, what are the topics that are on this or that. I prepared a lot in English, or I'm running into a certain problem. On the Q&As, without me and the camera involved, I like it to be non-question based. But this year especially, I'm getting a lot of questions about the grade 9 SHSAT, more than ever. And if you guys have particular math problems you want me to solve, email them to me. Send me a PDF. Take a photo of the problem with your camera, and as long as it's legible, make it legible. You want to make it easy on me to help you, right? So that's where we need to go. And again, please subscribe to the channel. I encourage you guys to do that. I have hundreds of YouTubes and hundreds of hours of YouTubes already on a lot of these topics, including grade 9 stuff. You can go look at some of the titles of some of the past ones I've done. They actually say grade 9 math. Some don't say grade 9 math, but they're still applicable. Like I did some streams probably 2 years ago now, based on the grade 7 and grade 8 state tests, and that you want to also be able to maybe look over some of those. And I might pull some of that back. I might do some of the harder problems from the grade 7 and grade 8 state test as a stream by itself. All right. Anyway, guys, have a great day, and I'll do more of these. And peace out. Have fun with your prep. You got about 80 more days. Bye.